So let's say we have the object. Let's say this is the object given as A, and we have another object. Let's say it is given as the object B, and assuming that the two objects are going towards one another in this case. Let's say that's the case. Let's say the separation distance between the two objects, it is given about, let's say, 40 meters. And say the object A is coming from rest. Let's say initial velocity is given as L. And assuming that it is moving at a constant rate of 8 meters per second square. And let's say the object B is moving from the initial velocity given as 2 meters per second. Let's say this is the case. So now, let's say it is moving at a constant rate of, let's say, 5 meters per second square. Where will the two have to meet? And after how long, and what are their respective final velocities at the point in which the two are going to meet? So now, what is the principle behind? So we don't know the time takes for the object A to have to meet with object 2, that is object A. We don't know the time takes for the object A to meet with object B, and even the distance itself, that's the displacement for object A, we don't know. And I don't know the time takes for the actually object B, and even its respective displacement, we don't know as well. But using the displacement formula, we understand that the displacement is equal to ut plus half AD squared. Now substituting the given parameters, the displacement for for object A is given as, now having the initial velocity as L corresponds to half this one as L, so which means we only have it as 4d squared. That is upon substituting acceleration to the formula. Now this is given as the equation 1. And how about the displacement, which is SB for the object B? We'll have it as 2d and plus 2.5 d squared. So this is given as the equation 2. So now you have to understand that at the end of the day, the summation of the distance for the object A as well as the object B will have to be equal to 40 meters, because the objects have to share that distance. That's the separation distance between the two objects. So whichever the case, you should have to understand that actually displacement for object 1 plus the displacement for object 2, and that should be the displacement for object A as well as the B. The sum has to be equal to 40. So in this case, we'll have 40 squared and plus 2d and plus 2.5 d squared. That will be equal to 40. Now in this case, you'll be able to solve for actually a term using the quadratic formula, in the sense that we'll have it as 6.5 d squared and plus 2d minus 40, which is equal to 7. Now this is what we have as the quadratic equation. So we'll have to solve for d using the quadratic formula. So what is the A? We have it as 6.5. And what is the B? We have it as 2. And what is the C? We have it as negative 40. Then I'll have to come up with the actually quadratic formula. So I'd like to deduce the term takes. So which means we'll have D being given as negative or minus B, or should be that in the square root of, now should be B squared minus 4AC, and that divided by 2A. So understand, you know how to make use of the quadratic formula there. Then I should have to substitute the given parameters. We'll have negative, should be negative 2 plus minus the square root of, now what is the B? We have it as 2. which means we have 4 plus 4 times C. What is the C? We have it as, what is the A? We have it as 6.5. And I will have negative 40. The essence behind is that I should have it as positive 40. Now let me just have to be much realistic in this case. So which means I'll have negative, it should be 4 times. What is the A? We have it as, so we'll have it as 6.5. That is times C, which is giving us the negative 40. We should have that in the divide by, and that is 2 times A. That is 2 times A, which is 6.5. So with calculator, what is 4 times? That should be 4 times. So now we can have it as this. So we'll have it as being given as, now have a time being given as negative 2 plus or minus the square root of 4, now plus 1040, and I divide by 13. So that's what you can have it, and that from there we should have it this way. So now which means we'll have it as negative 2 plus or minus, what is a square root of, now should be that we have it as a 36.2. So we have 36.2 and I divide by 13. So now which combination will give us the positive RT? Since we need to have the term which is the positive, so which means we'll have the term being given as negative 2 and I plus 36.2 divided by 13. So which means we'll have, that's 34. So the time will be given as 34.2 seconds. So that's the time of interest. Now should be divide by 13. So which means the time will be given as 2.6. So that's how the time will be deduced. We have the time given as t is equal to 2.6 seconds. So that's the time in which the both objects have to cover before reaching the point in which they are to meet. In other words, whenever the point in which the objects has to meet, the time covered will be that of 2.6 seconds. And how about their respective distances? How far should object A has to travel as well as the object B? So I have to substitute the time into their distance formula, that is 40 square. Now have 4 times 2.6, that the part 2 will have it in meters. So what is that? So now we can have it as, should be 27.8 meters. How about the distance traveled by the object B, which means we'll have it as 2 t plus 2.5 t square. So what would be that? Then now we'll have it being given as a 5.2 in the plus. What is this? Then I'll have it as 16.9. So that will be given in meters. And what is the sum of that one? That is 5.2. So which means the distance S2, actually SB, will be given as 22.1 meters. Now you can see that Actually, object A is the one which is moving faster compared to object B. Hence, it will have to cover about the more distance compared to the object B. So that's how we should have to understand about a such case of the motion. Now, what about their respective speeds at the point in which they have to meet? In other words, how fast will they move at the point in which they're going to meet? So we use the equations of kinematics as well. Now, much as we have the initial velocity, acceleration, and we have the time, that is 2.6, and I have the displacement that is given us now 27 point something we obtained. Now you understand that using the equations of kinematics, we can think of having this formula V is equal to AT plus C. This formula also we to have the final velocity for object A, and also for object 2 also use the same formula. Or else we can also use this as well. V square is equal to U square plus 2AS. So that one can work as well. So keep that in mind. So now, what if one object is moving at a constant speed? Let's say, now I should have to change the notation of the objects. Let me just have to use, let's say, object 1, and let's say this is the object 2. So now, assuming that the object 1 is moving at a constant speed, so which means the velocity will be given as, let's say, 12 meters per second. And let's say the object 2 is also moving from, let's say, now should be from initial velocity given as 2 meters per second. Let's say it is moving at a constant rate of, that should be 6 meters per second squared. And assuming that the separation distance is given as the 15 meters. So where will they meet and how far will the objects have to travel? And what will be their respective final speeds? You understand that for object 1, the speed is not changing, hence, since it is moving at a constant speed, even at the point in which the are going to meet, object 1 will have the same speed because it is not changing. The one that will have the new speed will be actual object 2, since it is accelerating at each and every point, there is change in actual speed. So keep that in mind. So, do you know the time takes for the object 1 to travel to meet object 2? We don't know. And how about the displacement S1? We don't know as well. And do we know the time takes for object 2 to travel? We don't know. And how about the displacement S2? We don't know as well. Now, since the object 1 is moving at a constant speed, it means the acceleration is given as well. Now, hence, initial velocity is the same as the final velocity. And that corresponds to having this way. Which means S1 will be given as Vt. That should be, which means the formula that we have to use for the displacement will be given as displacement is equal to UD since acceleration is equal to 0. And of course, instead of having U, we can use actually V. So which means we'll have Vt since the initial velocity is the same as the final velocity. So what is S1? We'll have it as 12t. This is equation number 1. And how about S2? Now for this case, we'll have it as 2d and plus 3d squared. Now this is given as the equation 2. So try to go through that one to have the time takes and their respective distances. And finally you'll be able to have the speed in which the object 2 will have, as it will have to meet the object 1. So using the same principle, you'll be able to have that one using the quadratic formula, of which you can work. And how about if both are moving at a constant, let's say constant speed? Let's say both objects are moving at a constant speed. What is the principle behind? You know, principle behind will be the same as well. Let's say this one is moving at a constant speed given as 20 meters per second. We don't know the time takes in the displacement S1, we don't know the time takes, we don't know, in the displacement S2, we don't know. But what's the principle behind? You should have to understand that S1 will be given as 12t, that is equation 1, and S2 will be given as should be 20t, that is equation number 2. And the principle behind it says that S1 plus S2 will be equal to 15, assuming that this is the separation distance. So keep that in mind. So that's how the head-on case of the linear motion can be evaluated or can be analyzed in that case. Thank you.